we use the pin as our cathode. We can see there is deposition of a brown solids around it. We are noticing some increase in the size.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored for competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
In this video, I want us to continue with our topic, that is electrolysis. We are looking at electrolysis. In the previous videos, we introduced the topic, we gave details about it. But for this one, we are strictly going to look at electrolysis of specified electrolytes. And for now, we are going to start with the electrolysis of electrolysis of copper to sulfate solution as the electrolyte. Remember, this electrolysis, remember we said there are several factors that determine the discharge. As we're talking of the electrolysis, one has to talk about the electrolyte. So in this one, the electrolyte is copper to sulfate solution. Being a solution, it means we have water and copper to sulfate salts. This means the ions in this electrolyte, the two ions, we have the cations and the anions. The cations in this, we have the hydrogen from the water, the hydrogen ions from the water, and we have the copper 2 ions from the decomposition of the complete decomposition of the copper 2 sulfate. So in most cases, you may need to know the equations. So the aqueous copper 2 sulfate will undergo complete ionization or decomposition to give copper 2 ions and the sulfate ions. The water will partially ionize to give hydrogen ions and the hydroxide ions. So the anions means that the anions we have the hydroxide ions from the ionization or decomposition of the water, and then the sulfate ions from the ionization of the copper 2 sulfate salt in the electrolyte. So these are the ions present. So we have two kinds of electrolysis. One, when using inert electrodes, that is either graphite or platinum as the electrodes. So we have an electrolytic cell. We are using an inert using inert electrodes, either graphite or platinum. So let us assume we have electrodes A and B. I think by now you can identify which of the two is an anode and which is the cathode. We said the one connected to a long terminal is the anode, and the one connected to a short terminal, which is negatively charged, is the cathode. So here we now know the ions present, the cations and anions. We are using inert electrodes. So these two electrodes may be a graphite material or a platinum material. So this means when we look at the anode, it means this is the positively charged electrode. It means that the hydroxide, because oppositely charged ions are the ones that migrate to that electrode. It means that here the hydroxide ions and the sulfate ions will migrate to this electrode. If we use an inert electrode, we follow the other two factors: the concentration of the ions or the position of the element or radical in the reactivity series. Since this is not a concentrated solution, it is just a copper to sulfate solution, it means that we are going to base on the position of these radicals in the reactivity series. We remember this from the previous videos. So this means the choice of the ion of the radical ion to be discharged or among these two will be based on the reactivity series. And we shall find that it's the hydroxide ions that will be discharged in the prevalence of the sulfate ions. Why? Because the hydroxide ions are less reactive compared to the sulfate ions. So at the anode, the hydroxide ions will be discharged by loss of electrons to form oxygen that will appear as bubbles at the anode, that will appear as bubbles, and water after the because balancing this, how many oxygen we had? 3, but we need to remove this from being an odd number. We put a 2 here, such that even this one becomes an even number. To make it a 3, to make it a 4 oxygen atoms, 4 hydrogen atoms. This means we shall balance it with a 4. But this one is discharged after loss of electrons, because this is an anion. These are anions. So this one will lose electrons. How many will it lose? Because we balance the equation basing on charge. Remember, if this one is negatively charged, if we are adding this negative charge, when it close to this side, it will become a positively charged. The charge changes from negative to positive. We are adding electrons. We are losing electrons. This one is discharged by losing electrons. So when this one is close to this side, it will become positively charged. So this means that it is going to lose how many electrons? 4 electrons to make this. So this is what will happen at the anode. When we use inert electrodes, we shall discharge the ions basing on the reactivity series at the anode. So the hydroxide ions and the sulfate ions will migrate, if you are writing the chemistry, will migrate to the anode, where the hydroxide ions will be discharged in prevalence of the sulfate ion since the hydroxide ions are less reactive. Hence, they will easily be discharged by losing of electrons, that is oxidation, to form oxygen that will be seen as bubbles forming around the anode and water. So that is simply the chemistry at the anode in words. If you want to rehear this, please, you can rewind the video. And then the cathode, at the cathode, the positively charged ions will migrate to there. That is the hydrogen ions and the copper 2 ions. Once at the cathode, we shall discharge the one that is less reactive, that is copper. Copper being less reactive compared to hydrogen, it will be discharged easily in preference of hydrogen by gaining of electrons, which is reduction, forming copper or brown solids of copper around the what? The cathode. So we shall find that the cathode, around it, we shall form deposits of copper around the cathode. And there will be no change on the what? On the anode, only bubbles of oxygen will be seen forming around the what? The anode. And we said that discharging of these positively charged ions involves gain of electrons. Involves gain of electrons to form respective atoms of the substance. So this is the electrolysis of copper to sulfate solution using inert electrodes. So at the cathode, we shall see deposits of copper. Copper is a brown solid. So the solid will be deposited around the cathode. And then at the anode, we shall be seeing bubbles of a colorless gas forming around the anode, and this is oxygen gas. These are bubbles of oxygen gas. Members, that is electrolysis of copper to sulfate using an inactive or inert electrode. That is strictly graphite or platinum. So this is, we want to demonstrate the electrolysis of copper to sulfate solution. This is copper to sulfate solution. We've just prepared it. Chemistry is practical. Everything can come out. So I'm going to use this optical pin. It's like silver or zinc coated. We want to coat it with copper from this. So it is that coated. It is shiny gray. We have our circuit here. We have our cell holder with a positive terminal and a negative terminal here. We have our sources of charge, which are the batteries. We have our wires. So what I'm going to do, I want to use active electrodes. I don't have a copper load, so I'm going to use this copper as my anode, this part of the copper. So I'll connect it to the positive plate, to the positive terminal of the cell holder, such that it becomes my anode. We want to really see, is it real or they are just narrating us stories? So I'm going to use my copper as my active anode to check whether all this wire is purely made of copper. And if it is made up of purely copper, or the wire, this part of the wire will decompose, will dissolve in the electrolyte. So you shall notice a decrease in the mass, the size of this part of it. I'm going to use this copper as my anode, and then I'll make sure that this one I want to coat with copper is my cathode. So since I will have some breaks in the explanations, I'm going to use a switch to put off and on, to complete the circuit and to break it. Yeah, here we go. So this is my terminal. I will connect to my switch. I'll connect this to my switch. Yeah, I'll make sure all the wire is on this side of the switch. And then from the switch, I will connect. So there is a gap here that needs to be completed. So I'll make sure this is my anode. I will immerse it into my electrolyte. So this copper sulfate is my electrolyte. Then, before this, I'm going to put my pin I want to coat with copper, my dry cells into the holder. We said I'm online. So I have my switch closed, then my electrodes. I want to see whether I can electroplate this. I think we are not seeing some reaction. I want to electroplate the other shiny gray. I don't know if we can note some reaction on our anode. We are seeing bubbles of the gas being given off, meaning that the wire we used is not purely copper. So the bubbles of the gas being given off are of oxygen gas. If we had the way of collecting the gas, we could see that it can be kind of a glowing splint or a lighting a glowing splint. But we use the pin as our cathode. We can see there is deposition of a brown solids around it. We are noticing some increase in the size of the pin. I think we cannot see it. This is copper. The solids formed are brown in color. It is because copper is being discharged from the solution. The copper ions are gaining electrons by electrolysis, by reduction process, and forming copper, which is deposited around the pin, like we are seeing. The copper is forming around the pin. So chemistry is real because whatever we teach is practically possible. So it is connected to the negative terminal like we saw. So there is discharge of the copper ions from the solution, forming the copper metal that is deposited around the pin. I think with that, the electrolysis of copper to sulfate solution using active electrodes is practical, and it is just not a total story. You've seen it and you've witnessed it yourself, I think. Alan once again. Remember, all this is possible because of Airtel, the smartphone network. We are capable of accessing all this because Airtel is making sure we have cheap data. I think we can compare between the two, the original pin and the one we've just coated with copper. Thank you. Don't forget to subscribe, to like our video if you like what we do, to even invite your friends. Don't forget to tap the bell if you really want to get more notifications. Members, but when we happen to use an active electrode, when we happen to use copper itself as the electrode, when, for example, if this is our electrolytic cell, these are the electrodes of copper. This is copper. If this is connected to the positive terminal and this to the negative terminal, this one becomes a copper cathode, and this one becomes a copper anode. The electrolyte will remain the same, copper to sulfate. This kind of electrolysis where we use active electrodes is commonly used in purification of copper during extraction and during electroplating, especially when we want to coat any metal with a copper filling, for example, the jewel. So what we do, we use, we get impure copper and use it as the anode. We use impure copper as the anode, and then we use pure copper as the cathode. Still, the same thing will remain at the anode. The ions will still migrate to the anode. Those are the what? The hydroxide and the sulfate ions. We are talking of the anode. However, since we are using an active electrode, none of them will be discharged. Now, the factor is different, is the type or nature of the electrode. Instead, the impure copper will start dissolving, the electric current will start dissolving the impure copper anode, and becomes, the impure copper anode will start dissolving and decomposing within the electrolyte to give ions of copper. And this will be as a result of loss of electrons. Members, when we use an active electrode, yes, the ions of the hydroxide and the sulfate ions will migrate to the anode, but none of them will be discharged because this is an active electrode. It's the electrode that will instead dissolve and decompose within the electrolyte to form ions of copper. So this is what happens at the anode. There will be decomposition instead of what? Of the electrode forming or increasing the ions of that electrolyte, of that substance used as the anode. And then it will remain the same. We are using copper. At the anode, hydrogen ions and copper 2 ions will be migrating to the cathode. The copper will still be the one that is deposited around the anode and the cathode, and we shall find that there will be an increase in the size of the cathode because more of the copper is depositing around it. And there will be a decrease in size, a massive decrease in size of the anode. Why? Because it is dissolving wherever the current passes through it to form ions in solution. So we are saying that the products formed at the anode when using an active electrode is different when we are using an inert electrode. The behavior of the electrodes are still changing. That yes, both when using an active and inert electrodes, the size of the cathode increases. Even in this one, we are seeing that copper is depositing around it. So the size of it is increasing as it is here. But the anode here, when using an active electrode, the anode dissolves within the solution to form respective ions of that electrode, the active electrode, into the solution, so decreasing the size of it. But still, the cathode is also increasing in size as a result of the copper that was in solution being discharged. Now here, two factors are applying at the cathode. One is position of copper in the reactivity series. Copper is less reactive compared to hydrogen. So it is easily discharged or reduced to form copper metal. These are brown solids around the cathode. But also, the second factor is also coming in of the concentration of ions. As the cathode, as the anode is dissolving, forming copper 2 ions, it is contributing on the already available copper 2 ion from the copper 2 sulfate. So we are also increasing the amount or number of copper 2 ions in the electrolyte as a result of dissolving of the anode. So here copper is discharged based on two factors. And therefore, the electrolysis of copper to sulfate when using an inert electrode is different from that when using an active electrode, keeping the electrolyte the same. And that is strictly about the behavior of the electrodes in both. This is applied when using an active electrode. This is applied in electroplating or coating of materials with copper. For example, you may need to coat your key, your jewel, like a necklace, like anything. You can use it as the anode, the cathode, and you use copper here as you can use copper as the anode, such that the copper dissolves in the electrolyte. If at all the electrolyte is copper to sulfate, whatever you use as the cathode will be coated with copper. Copper will come and form around it. Still, this electrolysis of copper to sulfate using active copper electrodes, it is also applied when purifying copper, where we use impure copper as the anode and pure copper as the cathode. We am to online. We appreciate whoever is watching, whoever likes our videos, whoever shares them. And this is simply electrolysis. Don't forget to invite your friends. Inshallah.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored as a competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.